Hey guys, I'm back with a new video, and in this video I'll be showing you how we can solve this capture the flag room from TryHackMe. I'll be solving it has 5 tasks, but I'll solve the first 2 in this part of the video, and I'll make a separate video for the next 3 part because it is kind of these 2 are related to crypto, and these 3 are related to forensics and steganography. So I'll be solving these first 2 tasks, and then in the next part we'll be solving this 3, task 4, and task 5. So let's get started. Before that, I need to join this room. This is a beginner level CTF challenge. Like, it is completely for beginners. If you are a beginner, then this is for you. First, try solving this room. After that, if you are not getting, or if you are stuck at something, then watch this video. So let's get started. So the first thing it is asking, this is translation and shifting. So translate, shift, and decode the following. Answer are all case sensitive. Fine. So this is something. Okay, so we can read it. Like, can you can you capture the flag? This is this is because I can read this because it is called lead language, and in lead language what happens that we write any any word or any sentence or anything, any alphabets in alphanumeric manner. Like A is written in 4, or you can just simply search for lead, and sorry, it is giving something else. Lead language. Yeah, so this is giving lead speak. Okay, so this is what it is giving us. Can go through this. I'm not going to do this. So see. Okay, cool. Let's see something else if I'm getting something. Okay, so lead is like a lead can be written in L or 1337, and here 7 is known as T, and E is known as 3, and L is known as 1. Fine. So it is kind of straightforward. So I'll write this, or I'll write this. Can you capture the flag? This is what. Yeah. So this is the answer. So the next question is given. It's binary. So let's decode it. Decode this binary. I'll be using CyberSafe for this because it is pretty good, and it has many decoding tools, and so I'll be using this. So yeah, so this is what we got. You can use other tools also. You can write a code for it, but I'm using this online tools to save time. You can go for it too. Fine. So the next thing is something garbage and not getting what is it, and if you're completely beginner, then it might you might stuck here because this is completely new for you. Okay, so for that I'll let you know that this is base 32 because, and how you can identify base 32. So base 32 has all capital letters, and there would be a equal to, like, this is called a tail of base 32, and by this tail you can identify it is base 32 or base 64. Now now if you ask me, that same tail also belongs to also present in base 64 too. So I will just let you know that this is base 32 because it has all the capital letters. Okay, so from that we can identify it as base 32. Fine, I'll just decode it from here. I'll delete it and paste it here. Okay, base 32. So this is what we are getting after decoding. So okay, let's submit the flag. Okay, good. I think it's not visible, so I'll just, okay, I think it's fine now, or it's cool. The next one is similar to the above one, but here we have some capital letters with some small letters with some alphabets with some numbers. So this is probably most probably base 64, because I've already told you base 64 contains small letters, capital letters and numbers also, and at the ending of it you'll get 2 or 1 equal to sign, that will help you identify base 64 or something like that. And this is not that it is not compulsory that it should be, there should be a tail, but most probably in many cases there should be a tail. So if you decode it from base 64, so you're getting this, each base 64 digit represents exactly 6 bits of data. Fine, we'll just submit the flag. Okay, so this is kind of straightforward again, because if anyone will see or anyone will get it, because we have a F here at the ending of it, and it is between 60 to 70 and 30s are there. You can also do main ASCII for this, like you can use the ASCII table here and you can decode it, but for now I'll just use the same cybersafe tool to, this is like, this kind of cybersafe is kind of a weapon for CTA players most of the time. So I'll just decode it with hex. Yeah, so this is the flag we are getting after solving this. This is what the answer is. This is a base, this is a hexadecimal encoded string, and after decoding it from hexadecimal we're getting this. Cool. So now this is something bit creepy here, and if you can see, it seems like, no, it seems like rod 13, because it is rotated 13 times, because you can see here 13. Okay, so that's a clear guess on my side. Don't judge me for that, because I do solve things this way and it helps me a lot. So I'll just, okay, so this is rod 13 because it is written rotate me 13 places. Okay, so what is rod 13? To the complete beginners, I'll just say you that if you are getting something like this kind of text or something not readable, then try for rod 13, because it may be rotated to 13 times, like R is rotated to 13 times and it is getting E. That's how it is rotated, and the vice versa will give you the exact plain text, the readable plain text. Okay, okay, so I've submitted that, and this is one more garbage, and there is another rot also, and it is rot 47. Okay, so what rot 47 does, I'll just, this is what rot 47 is. It will it will rotate the same text to 47 times. Okay, so that is what it does in rot 47. So this is what I get from rot 47, because it is rotated 47 times. The vice versa can give you the exact flag. Okay, okay, so dots and dashes, so like you can search for Google for it, but I'll not waste time. Just go for it directly, because it is a Morse code, everyone knows. And if you don't know, then don't worry, you are a beginner, you'll come, you'll get with it, I will be used to it. Okay, fine. So this is what we are getting after converting that Morse to small plain text. Just submit it. Okay, so we got that. Now again numbers, and this time you can also use the same process that we have used here in hexadecimal, but I'll use this as this is a decimal stuff, or you can also check here it is starting from 85, right? So check where is 85. 85 is here and it is u. Similarly you can go for it, and it is a decimal, so I'll be directly solving here. Okay, so decimal or base 10 we can say. Fine. What is this? This is a long text, very long text, and if you clearly observe it, you get a equal to sign here. So that means it is base 64. Why base 64? Because it has capital letter, small letter, numbers, and equal to 2. So it is base 64. So let's decode it to base 64, then let's see what we are getting. Base 64. Fine. Again, dots and dashes, and this time this is also again Morse code. And this cybersep tool has a cool effect, a cool thing you must know. Like if you're decoding something, or you can, if you're decoding multiple encoding, then you can put one by one. Like if you are doing base 64 here and you got a Morse code here, so just type search for Morse code and drag it and place it here. So this is what we are getting again, and this is binary again. So let's go for binary. We'll just drag it and drop it here. And okay, so again we are getting some nonsense here, and you don't get, if you're not experienced with it, then you won't get what it is. But let's, I know that what it is, but for you, you can just go for it like it is something related to base, something rotated, because we have, if you can see here, it is giving a clear text, or you can, if you are if you go for route 47 in Wikipedia, then you will get what symbols are used, and from that you can identify that it is a route 47. So we'll just type it, bring it, drag it, and we are getting, again we are getting a PSD, like decimal again. So let's decode it to decimal. Sorry if I'm going fast, I need to complete before time, in a short time. Okay, so this is what we are getting after multiple encoding, multiple decoding. So the this text, this particular text was encoded with decimal, then it was encoded with route 47, then binary, then Morse code, then by base 64. So it was multiple encoded. Fine, I'll just paste it here. Okay, so let's crack some hashes now, because this is what the next task is. A hash function is any function that can be used to map data of arbitrary size. Okay, so these are unique things. Like hashes are unique, and if you're not aware of it, then I will provide the link for decoding it. You can go for directly, you can directly go for this hashes to crack this hashes, and we will use cybersep and md5 hashing.net using this. So what is this hash? Or you can also go for example hashes to identify. This is a cool stuff from hashcat, and it kind of, it shows you how a hash start from. Like for md5, it starts from these are the length. Okay, so this is the length of md5 hash, and sa1, this is the length of sa1, or this you can identify by this, by looking into it. Okay, so there are lots of hashes, you can go through it. We'll provide the link in description for this one also. So let's see what the hint gives us. Okay, this method of encryption is no longer considered secure. It's an MD, but which one? Okay, so it's an MD, and this probably it may be like I don't know that. I can brute force it. Let's try brute forcing it. I'll try from MD5, and okay, so this is not MD5, so I think MD2 will work. Sorry, but MD4, no. MD, is that no, this is not MD. So let's try in hashcat. We'll just reverse look up it. We'll brute force it here in this website. Let's give it a time, give it some time. It will decode it and it will give back the answer. This is cool. Okay, so this is MD2. I don't know why it was not taking that particular value in CyberSafe, but we've tried MD2 and it was giving another hash. Fine. So we got this. What is this? Is the answer is MD what? Question mark. Okay. So this is the answer. Okay. So now the next is, let's see what it is giving. Better than MD2, but not good as MD5. So it may be MD4. Okay, so we'll again try this. We'll just try all the possible thing. It will brute force the thing, and you can go for it. Like you can do a lookup for it, but I won't waste time for it. Okay, so here we got the value of that hash, and this is the value. Digest the message algorithm. Okay, and this is MD4. You can see this is MD4. Okay, so first MD4, MD5 or MD2 was invented, then MD4, then MD5, and similarly it was going on. You can go with the history and all. So the next is, okay, we'll do the same thing here. We won't try any other thing. Okay, so let's wait till it get the answer for us. Okay, so this is something interesting here because it has capital letters and the numbers here. I think it is NTLM. Yeah, so yeah, if you go, if you just do some recon kind of thing, then you will get that Microsoft invented its own hash, that is NTLM, NTM. So before that, we'll just copy it and paste it here. Okay, so this is the next hash, and for this I'll be using. Do we have NTLM here? Do we have an option for it? Because no, we don't have NTML here. Okay, we'll just go for it. NTLM hashes, right? So Okay, let's find some cool thing for it. We can decode from where we can decode it. Okay, so I think MD5 decrypt will do that. Okay, just let yeah, so I just want to show you one more cool thing. You can go to this website nd5decrypt.net and you can put your hash and literally find it. So I'm putting it here and see. So it is giving possible kind of hashes. So it is giving a lots of options here, but the exact option is NTLM because I have already solved this kind of hashes previously also. So if you go here NTLM decryption, so I think we'll decrypt it. Sorry, I have encrypted it. So sorry. Okay, so we don't get anything here. Maybe we'll go for something else. Crack station maybe. Oh shit. I don't like this. I don't like this. Okay, so we don't get anything here. Okay, so let's try for this one. And what is that? I think. Okay, so this is saying my heart goes sha la 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 sha la la 5.2 times. Okay, so this is sha 5.2. Sha 512. This is what we're getting. I think it will decode it for us. So this is sha 5.2 algorithm, hashing algorithm, and it will decode the hash and it will give the plain text to us. Okay, 1024-bit blocks. Okay, so it is let's copy it and paste it here. Fine. So the next is this one is something interesting, but I think we can go for it here only. Just paste it here and we'll decode it. Okay, so this is SAR-256 and it is commonly used in blockchain. If you know what the blockchain is, it's a type of encryption. I don't know much about it, but it's interesting. Like it is used in cryptocurrency concepts. I'm not that sure about it. I'm not. Okay, the first SA. The next one is the first SA. And that is the first SA. So we'll just do the same thing here also. I think that is SA1. Yes. So let's decode it because the first SA was SA1 and after that others came into existence, but the first was SA1. Okay, so this is what we got, the OG. Okay, fine, the OG. So now we'll do this. So just I'll just check out what this is. I'll just go for some other NT LM stuffs decoder. Okay, we're not getting anything here. Okay, fine. So for now, I'm not getting that NTLM stuff here, but I think I'll just do it in next part. So till then, thank you.